February 14, 1944. The skies above Reckling Flight Test Center, Germany. At precisely 10:37 hours, Hauptmann Otto Stamberger eased back on the control stick of the sleek silver aircraft, its American insignia hastily overpainted with Luftwaffe crosses. As the P-51D Mustang lifted gracefully into the crisp winter air, Stamberger was certain the captured fighter would prove inferior to German engineering. "This will be a simple evaluation," he noted in his flight log later. "Nothing the Americans produce could match our Focke-Wulf 190D." Within 30 minutes, his entire understanding of the air war would be shattered. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the untold story of how a handful of elite Luftwaffe test pilots discovered the shocking truth about America's industrial might, encapsulated in a single captured aircraft, and how their classified reports warned of a technological supremacy that would ultimately help end Germany's complete dominance of European skies. Major Heinrich Beauvais, commander of the Reckling Evaluation Center, stood watching as the captured Mustang disappeared into the clouds. A decorated pilot with over 600 combat missions, Beauvais had personally overseen the evaluation of every significant Allied aircraft that fell into German hands. His technical reports, precise and unsparing, were required reading at Luftwaffe High Command. With 3,217 enemy aircraft claimed destroyed in the previous year alone, Beauvais and his fellow officers remained confident in German air superiority. "The Americans build bombers, not fighters," Lieutenant Colonel Werner Mulders had famously stated just 6 months earlier, during a high-level strategy briefing attended by Hermann Göring himself. "Their escort fighters lack the range to reach our homeland, and when they do, our pilots will make short work of them." The Reckling facility, situated 60 miles north of Berlin, had been a hive of activity since the captured P-51D arrived 3 days earlier. The aircraft had made an emergency landing behind German lines near Aachen after its pilot, Lieutenant James Morrison of the 361st Fighter Group, became disoriented in heavy cloud cover during a bomber escort mission. Morrison was now in a POW camp, while his pristine aircraft had become an object of intense scrutiny. Oberleutnant Kurt Wendell, Reckling's chief engineer, had spent 72 hours meticulously examining every component of the Mustang. His preliminary report noted the aircraft's maximum speed of 437 miles per hour at 25,000 feet, its service ceiling of 41,900 feet, and most alarmingly, its combat range of over 1,600 miles when equipped with external fuel tanks. These figures alone suggested capabilities that matched or exceeded the Reich's best fighters. "The Americans have clearly learned something," Wendell noted. "But numbers on paper rarely tell the complete story. The true test will be in the air under combat conditions with an experienced evaluator at the controls." Stamberger, with 104 confirmed aerial victories on the Eastern Front, had been specifically selected for the evaluation flights. A test pilot of exceptional ability, he had flown captured Spitfires, Yaks, and Airacobras. None had particularly impressed him. As he climbed through 15,000 feet in the Mustang, he began the standard evaluation procedure, testing the aircraft's handling characteristics, acceleration, and responsiveness. His first radio transmission came 18 minutes into the flight. "Control, Stamberger. The control harmonization is exceptional, responsive yet stable, continuing to climb." On the ground, Hauptmann Siegfried Nemier, another test pilot waiting his turn with the American fighter, listened with interest. A skeptic by nature, Nemier had dismissed Allied aircraft as mass-produced mediocrity, quantity over quality. The previous fall, he had authored a confidential report suggesting that American aircraft were designed for factory workers of limited skill to assemble quickly, not for combat effectiveness. While German factories struggled to produce 1,000 fighters per month across all types, intelligence reports indicated that North American aviation was completing an astonishing 400 P-51 Mustangs every 30 days from a single factory. Nemier and others had dismissed these figures as Allied propaganda. How could such production rates possibly yield a competitive fighter? In the cockpit, Stamberger continued his methodical evaluation. He put the Mustang through a series of increasingly demanding maneuvers, steep turns, rolls, climbs, and dives. At 22,000 feet, he tested its high-altitude performance, an area where Luftwaffe fighters typically excelled. The radio crackled again. Control, Stamberger. Engine performance at altitude is remarkable. The supercharger is unlike anything in our inventory. The P-51's Packard-built Merlin engine, a licensed version of the British Rolls-Royce design, incorporated a two-stage, two-speed supercharger that maintained power at altitudes where German engines began to falter. This technological edge, combined with the Mustang's aerodynamically clean design, was becoming increasingly evident to Stamberger. What particularly impressed him was the engine's smoothness. German power plants like the BMW 801 that powered the Focke-Wulf 190 were known for their reliability, but exhibited noticeable vibration throughout the operating range. The Merlin, by contrast, ran with a silky precision that suggested meticulous manufacturing tolerances, something the Germans had assumed impossible in mass production. The vibration levels are minimal, Stamberger noted in his flight log. Even at full military power, the airframe remains stable, enhancing gun platform stability. This would provide an accuracy advantage in combat. Another revelation came when Stamberger tested the P-51's fuel consumption. The Mustang's efficiency was approximately 32% better than the Bf-109G at comparable power settings, a difference that directly translated to its exceptional range. This efficiency stemmed not just from the Merlin's design, but from the aircraft's overall aerodynamic refinement. The Americans have clearly understood that range would be decisive in strategic air warfare, Stamberger would later write in his personal memoir. While we focused on rate of climb and acceleration for interception missions, they designed for sustained operations deep in enemy territory. It was a fundamental difference in philosophy that we recognized too late. As the test flight continued, Stamberger moved to combat maneuvers, simulating the dogfighting scenarios he had experienced hundreds of times over Russia. Here, surely, the American aircraft would reveal its weaknesses. The Focke-Wulf 190, Germany's premier fighter, was renowned for its roll rate and instantaneous turn performance, qualities that had made it the nightmare of RAF and Soviet pilots alike. At Recklin's radio room, the assembled pilots and engineers listened as Stamberger's voice betrayed a growing note of concern. The roll rate is comparable to our Focke-Wulf. Turn performance is better than expected. Acceleration in the dive is superior to anything I've flown. After 90 minutes, Stamberger brought the Mustang back to Recklin, performing a low pass over the runway before landing. The expressions on the faces of the ground crew noted his uncharacteristically gentle touchdown. He was treating the captured aircraft with unusual care, almost respect. As the propeller spun to a stop, a small crowd gathered. Stamberger sat motionless in the cockpit for nearly a minute before removing his oxygen mask and climbing down. His face, normally impassive, showed visible concern. "Well?" prompted Beauvais, who had been waiting for his chief test pilot's verbal assessment. Stamberger removed his flight gloves slowly. "It's better than our intelligence suggested." "Much better." That afternoon, Niemier took the Mustang up for a second evaluation flight. Unlike Stamberger, who had tested the aircraft's basic flight characteristics, Niemier's mission was to assess its combat potential against current Luftwaffe fighters. A Messerschmitt Bf-109G6 and a Focke-Wulf 198, the backbone of Germany's fighter force, accompanied him for direct comparison. The results were even more troubling. At 28,000 feet, the Mustang demonstrated a 20 miles per hour speed advantage over the Bf-109 and matched the Focke-Wulf. In climbing performance, traditionally a strong suit of German fighters, the P-51 equaled both. Most concerning was the American fighter's behavior above 30,000 feet, where the Luftwaffe aircraft began to struggle while the Mustang continued to perform effectively. The P-51 maintains combat maneuverability at altitudes where our fighters become sluggish, Niemier reported at the debriefing. This gives the Americans a significant tactical advantage, particularly when escorting their heavy bombers. Over the next week, 6 more Luftwaffe pilots flew the Mustang, including Major Walter Nowotny, a 258 victory ace from the Eastern Front. Each came away with the same impression. The P-51 was at least equal to German fighters in most performance categories and superior in several critical areas. But it was the Mustang's range that proved most shocking. With its internal fuel capacity of 269 gallons and provision for two 108-gallon drop tanks, the P-51 could escort bombers all the way to Berlin and back from bases in England, something German intelligence had deemed impossible just months earlier. The strategic implications cannot be overstated, wrote Beauvais in his classified report to Luftwaffe High Command on February 22, 1944. The Americans now possess a fighter that can escort their bomber formations across the entire Reich. Our ability to defend our airspace must be reassessed in light of this development. The P-51's technical evaluation also revealed other aspects of American industrial capability that left German engineers stunned. The aircraft's construction techniques emphasized simplified manufacturing without sacrificing quality. Parts were designed for rapid assembly using unskilled labor, yet the finished product showed precision and durability that rivaled German craftsmanship. Oberleutnant Werner Schroer, who specialized in materials analysis, documented the findings. The Americans have developed production methods that achieve quality through system design rather than individual skill. A single P-51 requires approximately 12,000 man-hours to complete versus 19,000 for our Bf-109. Their factories can produce 5 aircraft in the time we produce 3, with comparable or superior performance. This efficiency extended to every aspect of the aircraft's design. The Mustang's wing structure, for example, utilized a novel approach to manufacturing that reduced the number of machine parts while maintaining strength. Instead of complex forgings that required skilled metal workers, North American Aviation had designed components that could be produced using stamping presses operated by workers with minimal training. They have designed the aircraft not just for flight performance, but for production performance, noted Schroer. Each component has been engineered with assembly in mind. Guide pins, standardized fasteners, and self-aligning parts reduce assembly time without compromising structural integrity. Even more alarming to the German analysts was the quality control evident throughout the captured aircraft. Despite being manufactured in what the Germans had assumed were rushed conditions by inexperienced workers, the Mustang showed consistent precision in critical areas like control surface balancing, engine mount alignment, and hydraulic system installation. The wing panel gaps measured a consistent 1.2 millimeters throughout the airframe, a level of precision that German manufacturers achieved only with extensive hand fitting. Yet the American aircraft had clearly been built on a production line moving at unprecedented speed. Schroer's report highlighted another revelation. Their approach to quality assurance differs fundamentally from ours. Rather than relying on skilled craftsmen to detect and correct errors, they have designed production processes that prevent errors from occurring. The result is consistency that exceeds what we achieve through craftsmanship. The Mustang's Packard V1650-7 engine, delivering 1,490 horsepower, was similarly revealing. Lieutenant Ernst Kupfer, an engine specialist, reported, "The Merlin is manufactured to extremely tight tolerances, yet using methods suitable for mass production. Their quality control systems must be extraordinarily effective. We found virtually no hand-fitting of components, unlike our own engines." This glimpse into American industrial methods was perhaps more disturbing to the Rechlin team than the aircraft's performance itself. It suggested that the United States possessed not just the material resources to outproduce Germany, something already well understood, but the technical and organizational capacity to do so without sacrificing quality. By February 25th, the Rechlin evaluation was complete. The comprehensive 42-page report, classified Geheime Reichsake, Secret Reich Matter, the highest security classification, made for sobering reading at Luftwaffe headquarters. Major Wolfgang Spate, commander of the elite JG-54 fighter wing, was among the senior officers who reviewed the findings. "I initially dismissed the report as exaggerated," he would write in his post-war memoirs. "Then I encountered the Mustangs over Leipzig in March. Everything Rechlin had warned about proved accurate. The reality of American industrial might became increasingly apparent as the air war intensified in the spring of 1944. While German aircraft production reached its peak of 3,375 total aircraft in September 1944, American factories delivered 8,362 aircraft in that same month. Even more telling, North American aviation alone produced 761 P-51 Mustangs in August 1944, nearly matching Germany's entire fighter production. Oberstleutnant Hannes Trotloff, who had flown the captured P-51 during the Rechlin tests, faced Mustangs in combat on April 13, 1944, while leading JG-3 against American bomber formations. It was as if they knew our weaknesses, he recorded in his combat report. They operated at altitudes where our aircraft struggled, used their superior high-speed performance to dictate the terms of engagement, and their numbers seemed endless. The psychological impact on Luftwaffe pilots was profound. Major Johannes Steinhoff, commanding JG-77, described the shift in a confidential memo to Fighter Command in May 1944. Our pilots are increasingly fighting not just an enemy aircraft, but the entire American industrial system. They see the endless streams of bombers, now with fighter escorts that match our best machines, and understand the implications. This knowledge affects morale more than any tactical disadvantage. The captured Mustang's technical evaluation had predicted with chilling accuracy the challenges the Luftwaffe would face. By June 1944, coinciding with the Allied invasion of Normandy, Luftwaffe fighters were being overwhelmed not just by superior numbers, but by an aircraft that could meet or exceed their capabilities across the performance spectrum. Perhaps the most telling evidence of the P-51's impact came from Hermann Göring himself, who had initially dismissed the Mustang threat. After reviewing combat reports from April 1944, Göring reportedly told Albert Speer, "When I saw Mustangs over Berlin, I knew the war was lost." The story of the Rechlin evaluation nearly remained buried in classified archives. After the war, most documents from the test center were captured by Soviet forces, who recognized their intelligence value. It wasn't until the early 1970s that Niemier, who had survived the war and later worked for the U.S. Air Force, shared his recollections with aviation historians. "What struck me most about the Mustang wasn't any single performance figure," Niemier explained in a 1973 interview. "It was that the Americans had managed to create a fighter with no significant weaknesses. Our aircraft excelled in specific areas, the 109 in climb, the 190 in roll rate, but had clear disadvantages in others. The P-51 was good at everything, and its range made it strategically devastating." The captured Mustang itself met an inglorious end. After comprehensive flight testing at Rechlin, it was transferred to the Luftwaffe's Operational Evaluation Unit, Erprobungskommando 25, where it was damaged during an Allied bombing raid in April 1944. Rather than repair it, German technicians cannibalized the aircraft for parts and technical study. Its Merlin engine was sent to Daimler-Benz for detailed analysis, while its radio equipment went to Telefunken. By late 1944, as Allied air supremacy became complete, the lessons of the Rechlin evaluation were painfully obvious to every Luftwaffe pilot. German fighter production had reached record levels, 3,013 fighters in October, but new pilots received less than 160 hours of training before combat deployment, compared to 400 hours for their American counterparts. Fuel shortages kept many German aircraft grounded, while endless streams of Mustangs roamed the skies. Major Erich Hartmann, who would end the war as history's highest-scoring fighter ace with 352 victories, faced Mustangs repeatedly in 1944–45. Against the P-51, there was no margin for error, he later recalled. If they had an altitude advantage, you couldn't run. Their dive performance was too good. If they were below, you couldn't escape by climbing. Their power at altitude was too strong. You had to spot them first and use perfect tactics, or you wouldn't return. Werner Mulder's earlier assertion that American fighters would be easy prey had proven catastrophically wrong. By the war's end, the 8th Air Force alone had destroyed 5,558 enemy aircraft in the air and another 4,529 on the ground, many by Mustangs. Perhaps more significantly, the P-51 P-51 had transformed the strategic bombing campaign by enabling continuous daylight operations across the entire German Reich. Nemier, who later participated in the U.S. Air Force's historical analysis of the air war, offered perhaps the most insightful assessment. The Mustang was more than an aircraft. It was a symbol of American industrial and technological capability. When we examined that captured P-51 at Rechlin, we were really seeing the future. A future where quality and quantity weren't mutually exclusive, where mass production enhanced rather than compromised performance. This was a future Germany simply couldn't match. The legacy of those Rechlin test flights extends beyond their immediate tactical implications. They represent a pivotal moment when Germany's technical leadership confronted the full reality of American industrial capacity. The P-51 Mustang, with its combination of performance, range, and mass production, embodied the fundamental advantage that would ultimately determine the war's outcome. The Rechlin team also conducted detailed weapons testing on the captured aircraft. The P-51's 6.50 caliber Browning machine guns, each with 400 rounds of ammunition, provided impressive firepower. Although German fighters like the FW-190 carried a mix of 20mm cannons and machine guns with technically greater destructive potential, the Mustang's armament proved deadly effective in combat. The American .50 caliber is a compromise between our light machine guns and heavier cannons, noted Hauptmann Wilhelm Balthasar in the Ordnance Evaluation Report, but the reliability, rate of fire, and ammunition capacity make it devastatingly effective, particularly against aircraft engines and fuel systems. The P-51's gun harmonization pattern, optimized for convergence at 270 meters, created a lethal cone of fire precisely where American pilots were trained to open fire. German pilots typically engaged at closer ranges, but the Mustang's weapons setup allowed its pilots to begin firing from beyond the effective range of many Luftwaffe fighters. What particularly concerned the Rechlin analysts was the standardization evident in the Mustang. While Germany produced multiple fighter types with numerous variants and field modifications, creating a logistics nightmare, the Americans focused on refining a single basic design. This standardization dramatically simplified maintenance, repair, and pilot transition training. A pilot qualified on one P-51D can fly any P-51D, observed Lieutenant Gerhard Michalski, who specialized in operational analysis. Our pilots must often adjust to significant differences between aircraft of nominally the same type. The American approach saves countless training hours and reduces accidents. The radio equipment in the captured Mustang also revealed significant advantages. The SCR 522 VHF radio provided crystal-clear communication at ranges up to 100 miles. By contrast, many Luftwaffe fighters still used older HF sets with shorter range and more interference. This communications advantage allowed American formations to coordinate tactics more effectively and respond more quickly to changing combat situations. Perhaps most telling was the reaction of General Lieutenant Adolf Galland, the Luftwaffe's general of fighters, who visited Rechlin specifically to review the P-51 evaluation. After examining the aircraft and reading the test reports, Galland reportedly remarked to his staff, "This confirms what I have been warning about for months. The Americans have not just matched our best fighters. They have created an operational system that will be nearly impossible to counter given our current resources." Galland had already been advocating for the concentration of Germany's fighter force into a massive formation that could overwhelm American escorts. But the Rechlin findings made this strategy even more urgent. This led directly to the formation of Gefechtsverband Galland in early 1944, an experimental large-scale tactical unit designed specifically to counter Mustang-escorted bomber formations. Oberleutnant Karl-Heinz Meyer, who flew both the captured Mustang at Rechlin and later faced P-51s in combat with JG-27, survived the war and emigrated to Canada in 1952. In a 1985 interview, he reflected, "Flying that Mustang was a revelation. Everything we had been told about American technology being crude but mass-produced was wrong. It was sophisticated and mass-produced. That combination proved unbeatable." The P P-51D's revolutionary bubble canopy design provided pilots with unparalleled 360-degree visibility, a critical advantage in air combat, where spotting the enemy first often determined the outcome. When Stamberger first sat in the cockpit, he immediately noted this feature in his evaluation report. The unobstructed view in all directions represents a significant tactical advantage over our current fighters. German aircraft like the Bf-109 and Fw-190 featured heavily framed canopies with substantial blind spots, particularly to the rear, where enemy fighters typically attacked from. The Messerschmitt 109's canopy, with its multiple framing elements, had been cited in combat reports as a contributing factor in pilots failing to detect approaching threats. In the Mustang, I could see in every direction without moving my head, Stamberger noted. This constant situational awareness would be invaluable in combat, particularly against multiple opponents. The German engineers at Rechlin also examined the P-51's auxiliary systems. The hydraulic controls operated at higher pressure than German equivalents, allowing for smaller, lighter components without sacrificing reliability. The electrical system featured redundancies absent in Luftwaffe fighters, including backup circuits for critical flight instruments. Even the seemingly mundane aspects reveal careful engineering, wrote Technical Officer Ludwig Hoffmann in his assessment. The Americans have not simply built a fighter with impressive performance figures. They have created a complete weapons system optimized for its strategic role. Another feature that stunned German engineers was the Mustang's fuel system. With internal wing tanks, fuselage tanks, and provision for drop tanks, the P-51D carried up to 489 gallons of fuel, giving it twice the range of any operational German fighter. This wasn't just a matter of adding more tanks. It required sophisticated fuel management systems and an aerodynamically efficient design that maintained performance despite the additional weight. "We had nothing comparable," noted Wendell in his technical assessment. Our attempts to extend the range of the Bf-109 and Fw-190 with external tanks compromised performance to an unacceptable degree. The Mustangs suffered minimal performance degradation even with full tanks. The P-51's cockpit ergonomics impressed the Luftwaffe pilots. The bubble canopy provides unmatched visibility in all directions, wrote Stamberger in his detailed flight report. In combat, this would confer a significant advantage in situational awareness. As the war progressed, the Mustang's impact became increasingly apparent. By March 1944, 8th Air Force bomber losses dropped dramatically as P-51 escorts became standard. During Big Week, February 20th to 25th, 1944, American bombers struck aircraft factories across Germany with Mustang escort, destroying an estimated 75% of German fighter production capacity. Ironically, just as the Rechlin report was being circulated among Luftwaffe leadership, American Mustangs were demonstrating everything it warned about in combat over Germany. On March 6, 1944, P-51s of the 4th Fighter Group shot down 15 Luftwaffe fighters near Berlin for no losses. 3 days later, Mustangs escorting bombers to Brunswick destroyed 24 German aircraft. The statistical evidence of the Mustang's dominance mounted rapidly. By May 1944, the 8th Air Force's 3 P-51 groups, the 4th, 352nd, and 355th Fighter Groups, were achieving kill ratios of better than 4-to-1 against the Luftwaffe. Major George Preddy of the 352nd Fighter Group shot down 6 Bf-109s in a single mission on August 6, 1944, a feat that would have been impossible without the P-51's combination of range, performance, and firepower. For the Luftwaffe pilots who had evaluated the captured Mustang, these developments came as no surprise. Their warnings had been accurate, but ultimately unheeded. Germany simply lacked the industrial capacity to counter the American threat, regardless of how clearly it was understood. The Rechlin evaluation also shed light on another aspect of American air power that would prove decisive: the training pipeline for pilots. Documents found in the Mustang's cockpit included standardized checklists and tactical manuals that revealed the methodical training system used by the USAF. This system allowed American pilots to achieve competence much more quickly than their German counterparts. Their training emphasizes standardized procedures and teamwork, noted Hauptmann Rudolf Sinner in an appendix to the Rechlin report. While less individualistic than our approach, it produces large numbers of adequately skilled pilots who can function effectively as a unit. Our focus on creating exceptional individual pilots cannot match their output. This observation proved prophetic. By late 1944, newly assigned Luftwaffe pilots were reaching frontline units with less than 120 flying hours compared to 350 to 400 hours for American pilots. The quality gap was becoming as significant as the quantity disadvantage. Major Hans-Gunther von Kornatzky, who had supervised tactical evaluations at Rechlin before being assigned to combat duty, encountered Mustangs over the Rhineland in September 1944. They flew with a confidence that came from superior numbers and thorough training, he reported. Even their less experienced pilots demonstrated solid, fundamental skills and disciplined formation tactics. The implications extended beyond the immediate air battle. As Kornatzky observed, the American approach to warfare, standardization, mass production, and systematic training, represents an entirely different philosophy than ours. We value the exceptional individual. They build exceptional systems. In a war of attrition, their approach proved superior. As Allied armies advanced into Germany in early 1945, the Rechlin test facility was evacuated. Many of its records were destroyed to prevent capture, including most documentation related to the captured P-51. The German aircraft industry, once the pride of the Reich, lay in ruins, victim not just of Allied bombing, but of the fundamental industrial disparity the Mustang had so clearly symbolized. In the final analysis, the story of the Rechlin evaluation represents more than a technical assessment of an enemy aircraft. It illustrates how technological advantages in warfare often stem not just from scientific knowledge or engineering skill, areas where Germany excelled, but from the integration of design, production, and operational deployment on a massive scale. The P-51 Mustang was not significantly more advanced than its German counterparts in any single aspect, but its balanced capabilities, produced in overwhelming numbers, proved decisive. For the Luftwaffe pilots who flew the captured Mustang, this realization came too late to change the war's outcome. Their professional assessment, however, stands as one of the most prescient analyses of the fundamental shift in aerial warfare that would define not just the remainder of World War II, but the decades that followed. An era where industrial capacity and systems integration would prove as important as the skill of individual pilots or the genius of aircraft designers. Captain Stamberger survived the war and rarely spoke of his experiences until shortly before his death in 1989. When asked about that very memorable February day at Rechlin, he said simply, "When I landed the Mustang, I knew what was coming. We had glimpsed the future of air power, and it did not belong to Germany." And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.